You're listening to ChainLeak, the crypto news podcast with your host, Joshua Roomsberg. Follow and subscribe today.
Welcome to the ChainLeak podcast. I'm your host, Joshua Roomsberg. Today's episode is about Taraxa, EVM Compatible BlockDAG. Today's guest, Stephen Poo. Welcome to the show, brother.
Thank you very much for inviting me, Joshua. It's really great to be on your show.
Yeah, no, this has been a long time coming. So you are the co-founder of Taraxa. Can you give us a little background of where you started and how this network has evolved over time?
Okay, so hopefully you're okay with kind of a long-winded history.
No, you're good.
My path towards entering the crypto industry has been pretty long. So I first heard about Bitcoin in 2013, beginning 2013, from a classmate of mine named Bobby Lee. So he was one of the people that co-founded the first BTC exchange in China.
Okay.
So at the time I was actually in China, and so checked it out. Didn't quite get it. When the Central Bank of China banned BTC in 2014, one of many bans to come, right? So
right.
I kind of thought it was kind of game over. And then, so I stopped paying attention to it. And in 2015, another Stanford classmate of mine, Alex Liu, who was creating an exchange in Taiwan, was telling me that I should check out Ethereum. He said, this is sort of the technology that's underneath all these cryptocurrencies. And you should go check out this Russian kid that's been hanging out in Shanghai, right? So it was Vitalik. So he was coming to Shanghai a lot because the Wanxiang Group was one of the first institutional investors in Ethereum. So I was going to a lot of these meetups, and at the time, I think all of the use cases that people were talking about were enterprise use cases. So it made the whole thing seem like kind of an IT consulting type of ecosystem. And I was like, I really don't want to be like an IT outsourcing company. That it seems kind of strange. And so I thought about that for a while. Still didn't quite get it. I think what really got me to really look at it again was the third time I had another Stanford classmate of mine who quit his job as a trader in Hong Kong and joined a startup that was building a decentralized exchange. And that was very interesting. His partners were at the time the largest ICO platform in China, and they were affiliated with the Wanxiang Group as well. So that time, I think what really made a difference there was because I was working. I'd done a lot of startups in my career, and at that time, I think around 2017, my job was an associate partner with Monitor Deloitte. So I was doing a lot of large-scale strategy projects for a lot of corporations, very large companies. And the thing that I started noticing a lot was these corporations were horribly inefficient. They weren't capturing kind of, innovations. They were very inefficient in their processes. There's a lot of friction and lots of inefficiency everywhere. And they weren't performing and they weren't innovating. And they're all very scared that they're going to be replaced by some startup. So I kept asking myself, what is going on? What is fundamentally wrong with these companies? And I had come to the conclusion that it's that human organizations don't really scale that well, right? Yeah. So when I started thinking about kind of decentralization, it was really a way to kind of build trust into processes so that they can be automated. I mean, I think one of the biggest barriers that prevents automation from happening, I guess within the human civilization in general, is really trust. Right? It's not technology, it's really trust. Do you trust that these processes are going to be correctly enforced? Do you trust that there's no strange things happening in a black box? So the decentralized network kind of paradigm really allows you to trust processes and be able to verify them very, very easily. And it was really an interesting way to reduce friction, to just massively automate so many processes. I know this sounds a little bit abstruse, but I was getting really frustrated, I think, doing 2-3 years of these massive consulting projects where these companies pay me millions of dollars, and I can't really figure out a way to fundamentally solve their problem, because the problem is just, the way that humans coordinate ourselves, right? The way we coordinate business activities, capital, allocate capital, all kinds of activities have so much friction between all of them. As you get big enough, you start becoming worse. So that was like kind of the third time was the charm that I really started thinking that decentralization was very, very, very interesting, because there was never really a technology ever, I think, in human history that was designed to create trust, right, in processes. So that was what really got me kind of into this rabbit hole. And after talking to a lot of these other people that were in it sort of earlier, obviously the type of applications were, far ranging, right? I mean, the idea of like a decentralized exchange is also kind of a trustless way to allocate capital, for example.
That was the biggest thing that I realized when I entered the industry, was the decentralized aspect of it.
Exactly.
I've had money orders or bank transfers where the funds weren't available for 3 to 5 days, or the conversion rates were, I'd lose $1,000 on a $5,000 deal. I didn't like that these banks were able to do that in the conversion rates in between countries. When you are receiving payments as a business owner, you lose a large percentage of what comes in. So with blockchain and the way you could receive a payment and there was no intermediary that was taking a chunk of that, I thought that was mind blowing. And here we are today.
Yeah, exactly. It just introduces so much efficiency, right? I mean, I think during the early days, I mean, still today, like I think people talk about, oh my God, these networks, there's so much redundancy, there's so much wasteful, it costs so much energy. And I tell people, look, you're not comparing it to the right things, right? You should actually compare it to the massive amount of resources that are being poured into traditional centralized systems so that they can trust each other. And the $1,000 fee, what you just mentioned, the delays, all those people checking everything over and over again. So that's what you should be comparing it to. So compared to that, decentralized systems are extremely efficient. So it's a very, very, very kind of an efficient way. It's a very simple way, right, to really inject trust into a lot of things that we do. So anyway, as soon as I saw that, I started thinking, well, how can I get involved? And in the beginning, it wasn't kind of really obvious how I would get involved. So I kind of like, started just volunteering my time with a lot of different projects, designing something like this, designing something like that. And through the whole thing, I discovered that, existing blockchain systems were incredibly slow and expensive. So, and I wasn't trained as a computer scientist. I was trained as actually a hardware engineer. So I actually hunkered down and just started reading like, academic papers. Back then, there weren't even that many white papers. So I started reading a ton of academic papers on distributed systems. So kind of like just learning things as we go. And I discovered that there were just a lot of ways, a lot of well-known kind of concepts and architectures and designs that were in distributed computing that just weren't being used in blockchain systems. And it made sense, right? I mean, I think Satoshi and Vitalik, when they designed this thing, it was like the first one to exist. So they made sure that security was the first and foremost thing to make sure that it was secure. They didn't really think about, well, let's make it as fast as possible, so then you run into risk of things going bad. So there was definitely a lot of room for improvement, and I thought, hey, why don't we kind of try to crack that nut a little bit and see if we can make some contributions to the world when it comes to actually improving these layer one infrastructures.
That was when I look at other blockchains that are available in the market today, that's one thing I always pay attention to first. And I get a lot of kickback, whether from friends or other people in the industry, when I state the specific aspects I look for in a network. And number one is always speed for me. I look at them things I've had to endure in the past, being a business owner, and them delays, the process of a transaction getting kicked back, whether it's the credit card processor or the third-party intermediary kicking the transaction back. Then I have to contact that customer again, and we have to go through the process 2, 3 more times before the payment goes through. And with blockchain, that transaction is final as soon as it comes through. So speed is a big factor. Finality is a big factor. And then the ability to build out applications on top of a network. That's another big aspect. And I know as far as Bitcoin goes, they're starting to build out infrastructure to where you can do more on the Bitcoin network. But that was how Ethereum got a leg up. They introduced smart contracts. So how does the Taraxa network compare and differ from the Ethereum network when it comes to speed, the ability to build out more infrastructure, and the finality of the network?
Yeah, so that's a really good question. So at the time when we designed this, we were trying to figure out what is a good architecture to use. And at the time we were reading this paper called Ghost,
GhostDAG? Yeah.
Phantom GhostDAG, right? So it was written by Sompolinsky, Wyborski, and Zohar. So Sompolinsky and Wyborski, you guys might have heard of them. They're kind of co-founders and core members of the Casper project. So these are the guys that actually invented BlockDAG. That was a very interesting paper. Yeah, when I read that, it was like, wow, this makes a lot of sense. It doesn't, like, every step of the way was mathematically proven to be secure, and we wrote some initial code and simulate very simplified code for simulation, and it just works, right? So we were very impressed with this algorithm, and we said, hey, let's sort of dive into that. Initially, we wanted to actually. I'll tell you about this and tell you about some of the other things that we tried before that. But this was not the first thing we tried. This was like the third or fourth thing that we tried. So it worked out pretty well. And so the next few design decisions was, so first of all, we always wanted to build a application platform, right? So it had to have smart contracts. And it was sort of a no-brainer for me that we would be EVM compatible. I think primarily because at the time, and I think still today, you can make a compelling argument that vast majority of Web3 developers are EVM developers, right? They use Solidity, they're in the EVM ecosystem. And I recognize that there was so much tooling at the time because, back in 2018, Ethereum had already had like 3 years kind of a head start in building this big ecosystem of development tooling, testing environments, deployment environments, frameworks, all kinds of stuff. And if we were EVM compatible, we would be automatically compatible with all the tools. And one thing that developers absolutely hate is to learn a whole new set of things, right? So we said, hey, it just makes sense to be EVM compatible. So, and then lastly, we wanted to be proof of stake, just because we thought that the world probably doesn't need a ton of proof of work like layer ones. So I mean, I can definitely see the value of having one or two proof of work. There's an elegance, and there's a lot of arguments that kind of proof of work chains would be really good for for store of value, for currency, or for whatever, right?
Specific concepts within the industry.
Yeah. I mean, but if you wanted to kind of scale up a lot of applications, proof of work seemed just kind of expensive. So we said, let's go with proof of stake. At the time, proof of stake, I think, just came out. I think the first project to really deploy that en masse was Tendermint, which made it into Cosmos, I think turned into Cosmos. So we're reading into that. So those were kind of the early design decisions. We're going to do BlockDAG. We're going to do a native integration of EVM standards on top of it, and then we're going to go with proof of stake. Integrating the EVM natively into BlockDAG or any kind of high throughput architecture was extremely difficult. We didn't realize how difficult it was until we're like halfway through. There were a lot of bottlenecks and pitfalls in the EVM itself.
Now, let me stop you there. Yeah. For an end user, like I feel like I'm well-versed in the industry, but there are still some concepts and things that I don't understand. So for an average user in the industry who might come across this interview, can we break it down, the process it took for you guys to implement EVM compatibility into the BlockDAG infrastructure? I feel like that's something that's going to be hard for a lot of people to wrap their head around. Just like you just mentioned, it was hard for you guys to implement that into the BlockDAG infrastructure. What does that look like from the outside for an end user?
Yeah, so I think if you were just looking at BlockDAG on its own, right? So the BlockDAG paradigm is very elegant. And we actually had to modify the BlockDAG quite a bit too, because I think the paper that was originally written didn't specify an algorithm, or didn't specify an efficient algorithm for rapid convergence. But this is probably getting too detailed.
Okay.
So we had to do a lot of innovation and work around that as well. So we were implementing the BlockDAG. We were figuring out a way to kind of enforce rapid convergence, and so the BlockDAG was kind of working pretty well towards the end of 2019, I would say. But then that only sent like simple coins, right? It's like I sent you a coin, you send me a coin, that kind of thing. The issue with putting EVM on top was that the EVM had all these bottlenecks. One of the more significant bottlenecks that we saw was that it when it was this might be too technically detailed, but when it was writing into the state DB, it always went through the Merkle tree first. They had a data structure called the modified Patricia Merkle tree, and that was what guaranteed kind of the integrity of the Ethereum state. And this Merkle tree is a very efficient way to store things, but it was a very inefficient way to read and write, right? There's always trade-offs. Like you have one thing, you can't have something else. So it was really good at storing things efficiently in very tiny sizes, but it was not good at reading and writing. So the fact that it needed to read and write every time through the Merkle tree really limited the EVM to 100 TPS. So I mean, all these, so that was pretty bad. All right, so we're like, well, what? How can we bypass this? How can we bypass this bottleneck? Well, the way to bypass the bottleneck is not to require that all reads and writes go strictly through the Merkle tree, and it actually kind of went parallel with the Merkle tree and the state DB. But why? Like, why did they make it that way? Right? There was a reason why. The reason why they made it that way was because Ethereum had probabilistic finality, right? So on Ethereum, just like on Bitcoin, you kind of wait, a few blocks, and you're like kind of 60% finalized. You wait like another few blocks, you're 90% finalized. You're never 100% finalized because it's probabilistic. And because of the probabilistic nature of the finality, there's always a risk, a non-zero risk of rollbacks. Like you could have bet on the wrong block and the chain needs to reorganize, right? You need to reorganize. This happened a few times, I think, in Bitcoin as well as in Ethereum. It's happening less and less, obviously. But so when you do a reorg, you do need to make sure that you're kind of rolling it back exactly according to the right order. So that's why you need like the Merkle tree to kind of be able to know exactly how each state was flowing and exactly how to roll it back, and that you're not making any mistakes while you're kind of reading and writing into it. So then we realized, okay, in order for us to kind of parallelize the read and write into the Merkle tree with state DB, we had to introduce true finality, right? We had to guarantee zero risk of rollback. So
that's nasty. So
this
that's
is where we realized that, this is where we realized we had to another layer of consensus in parallel to BlockDAG, which is the PBFT process, to make sure that there is true finality. Like there's no, so one PBFT block, which will tell you that things are finalized 100%. It's not probabilistic. It's not like, well, 6% now. So then we're like, holy crap, we have to lay in another layer, and a secure PBFT process was not trivial to implement. So we went back, and this was towards the beginning of 2020 when we realized this, and we started implementing the PBFT process. So that took a really long time. So this is why I always joke that if we had just released something that was not as secure, or if we weren't like sort of sticklers for technical correctness, we
Yeah.
could have released mainnet probably in 2020 or 2019. But because our entire team was like, you have to do this correctly, it took a lot more years to actually get it correct. When you have two layers of consensus running asynchronously, the BlockDAG with its own kind of implicit loading and convergence consensus, along with the PBFT and the EVM, we had to make heavy modifications to EVM as well. So that I think delayed us by like 3 years at a minimum. So it was a non-trivial thing to work out, but I think we're very, very happy with the result because there's really nothing like it on the market, right? So
Okay.
fundamentally, I think BlockDAG it's just a superior architecture, and it doesn't force anything. It's very organic in the way that it produces blocks, and it's very organic in a way that kind of orders blocks. And the PBFT process is complete asynchronous, so it's kind of like this section is finalized, this section is finalized, so it doesn't really interrupt anything. So everything kind of just flows really well. And of course, it's EVM compatible, so you can run pretty much anything, on top of it. And so we were very, very excited to, be able to launch the mainnet last year. Still 2024, yeah. April of 2023, and we were very, very excited because there was nothing, and there still is nothing like it in the world. And
Okay.
we really think this is this is a very unique piece of technology. We been talking to a lot of developers trying to get them to try it out. Yeah. So.
Now, you just mentioned that the Taraxa network is a 3-layer system. Is that correct?
Yeah. So you have the BlockDAG, you have the PBFT, and of course you have the EVM. Yeah. So.
Okay. Now, what is the transaction speed for finality? When do you guys have certain finality?
So right now, the finality latency is around 3.7 seconds. So you have one. So there are several ways to look at like kind of latency, right? So the first thing you look at is how quickly are your transactions included in a block. So as far as kind of application developers, this is something that they actually care about a lot because I think on other networks, even really fast networks, it actually takes a while for your transaction to get included in the block. But our block inclusion is instantaneous because the BlockDAG architecture, there are lots of different nodes that are working together to include transactions into blocks. So it ends up, yeah.
No, you're good. Oh, man. So that was the next question I was going to ask is, out of this 3-layer system, which one is closing blocks the fastest? It's going through the BlockDAG? That's how you're getting the 3.7?
So it goes through the BlockDAG. And that's the first time it kind of gets into like the system. And then it goes into the PBFT process, which finalizes sections of the BlockDAG. And then once it's finalized, it just processes all the transactions that have been correctly ordered within, that section of BlockDAG. So it's kind of like 1, 2, 3, and then it's asynchronous. So by the time it finishes, one thing, it does another thing in parallel and it jumps into the next thing. So it kind of just works along smoothly without any interruptions. It's not waiting for it. I mean, that's the other thing that we kind of didn't quite like about a lot of the existing layer 1 systems is that there's always a lot of waiting. Like people just kind of waited for this thing to finish and did that. So everything was done kind of sequentially. So we tried to introduce as much parallel processing as possible so that things can be done obviously in parallel. So you're not sitting
more efficiently as well.
Yeah. I mean, if you look at the way, I think one interesting way, this is not something that normal users will notice, but if you run a validator for layer 1, you actually want to see what the utilization rate for a lot of the cores that they have, right? So you have like a 4-core, if you're like, super
8-core,
expensive.
16-core, yep.
Yeah, like, 16-core, whatever. You want to see how many of those cores are being used. So in a lot of these, I would say less well-designed layer 1s, a very small percentage of the processing power is being used. That means they're not taking advantage of, they're wasting all the processing power. It's not being parallel processed. So they're just kind of sitting around waiting for one thing to the next to happen. So that was another thing. At the time, I think we were profiling all these Ethereum nodes and watching the system resource consumption. So I mean, obviously the goal is to maximally use whatever resource you have to make it go as fast as possible. But yeah, going back to what you said about the finality, the 3.7 second, we're actually going to be releasing a roadmap very soon for 2025. But 3.7 second on average, this is a very kind of conservative number. We're a very small team, so we can't do everything at the same time. So the 3.7 second is really a parameter that we kind of set internally to maximize liveness guarantees, like something good happening in the network. But it's extremely conservative. I think we can do way better than that. I think everyone on the team agrees that we can do way better than 3.7 seconds. We'll probably do like 1 second if we wanted to.
Right.
So next year in 2025, I think we're going to spend a lot of time trying to figure out how to optimize things like throughput, benchmarking it, optimizing things like latency and benchmarking it. One of the things that we also quite dislike, I think, in today's layer one field is that people are coming out. First of all, they're coming out with extremely crazy claims, right? Like, very, very, very high numbers throughput, very, very low latency numbers. But all of these numbers are not observable on their mainnet. They're all done in some secret network that only they have access to, and they release these papers about, whatever. Here's all the things, and they have all these simple. I mean, even the somewhat honest people, they would talk about the simplifying assumptions that they make, which do not like they're not true in the real world. So that's one of the things that always bug me, because obviously to an end user, even to a lot of developers, right, who don't design layer ones, they will look at some of these numbers, are like, oh my god, why are you not as good? And I'm like, these numbers are not true. That's why so what we're going to do is that we're actually going to do a pretty involved series of benchmarks on our mainnet, not on some secret testnet, that everyone can see and verify. We have third-party kind of partners who are working with us to kind of audit what we're doing to make sure we're not cheating, right? And we're going to be publishing those reports. So that's one thing that I think we're really, really keen on getting out, to the wider crypto community. The other thing I think we're very keen on getting everyone to know about, and this again is a no-brainer. A lot of these validators, minimum requirement for other layer ones, they are like supercomputers. They cost so much money to run, thousands and thousands of dollars a month to run. Not only that, like, these other companies, these foundations or whatever, they actually enforce, the fact that your hardware can't be lower than whatever we require. So it's really a form of centralization in our mind. I think when we think about decentralization, and we're really decentralization maximalists, like this is like the thing we care about. Because if it's not decentralized, like, what's the point of being in crypto, right? You just go do some internet startup and whatever. But one of the critical thing about decentralization is accessibility. That anyone or as many people in the world as possible can afford to run a validator node. If your validator node is several $1,000s a month, I mean, that knocks out like most of the world, right? I mean, if you're in the U.S., maybe a couple $1,000s. I mean, even in the U.S., a couple $1,000s a month is a lot of money. I mean, you imagine going to other places in the world. It's like it might as well be a couple millions. I mean, it's just it's
people can't do that, right?
Yeah, it's a huge number. So what we noticed that there's like a 10x to 20x difference between the resource requirement, how expensive it is to run one of our nodes versus how expensive it is to run one of their nodes. And doesn't take like a rocket scientist to realize if your nodes are really expensive, use extremely expensive hardware, it's going to run faster. I mean, it's
that's the way it breaks down, right?
Right, that's the way it shakes out. So it's not like it doesn't take a brain surgeon to realize that. So
what are the requirements to run a Taraxa node?
So so at a minimum level, I might be misquoting this because maybe I should be looking at the numbers, but yeah, it's I think 2 to 3 cores and I think 4 to 6 gigabytes of RAM. We have these benchmarks coming out. Yeah, I mean, if you look at some of these other guys, they're easily 10x or sometimes even 20x.
Is there a token requirement that's included in the process as well?
Yeah, so in order to produce blocks, I think the requirement is that you need to have 500,000 Terra delegated to it. And you don't have to, it's not something you have to pay yourself, like as the validator. Other people delegate, their stuff to you.
Okay.
So that's also an extremely low kind of a threshold because we wanted as many people as possible to come in, but we didn't want to just make it like we didn't want to make it just like one, because if it's one, then it's kind of pointless. You're not going to be producing blocks for like a year or something. It's just too unlikely. So we want to make sure that at least is some minimum threshold. I mean, that's really the idea, right? Just make it as accessible. So if you're able to achieve high performance and your node is like 10x cheaper than everyone else's, that's what I call decentralization, right? And that's, performance.
Then you have more nodes on the network around the world as well.
Instead of able to have more
big
nodes,
companies that have 50, 100,000 to put behind node infrastructure can get on the network. You have the ability as an end user to participate in the Taraxa network. Is that what you're saying?
Exactly. Yeah. We want as many people to be able to run the validator as possible. Now, so I mean, we've had developers coming to us. I mean, I think we just had a AMA about a month ago with one of the ecosystem projects called Terra 2. They're an explorer. And one of the things that they said, and this is echoed by a lot of people who run our validators, is that Taraxa has probably the easiest to run validator node. Like it's for someone with a minimum amount of experience in Linux, they can set up a node and get it up and running with almost no hassle whatsoever. So we want to make it easy. We want to make it cheap, and accessible as possible. Yeah.
Do you recommend people running their own servers or using cloud infrastructure?
Whatever it is they like. I mean, if you want to be a kind of a decentralization purist, you say you run your own machine.
Yeah.
But that's, I think very few people do that. Like even I don't have a machine in my house that's on 24/7, right? Like your own house or your own basement is just sort of not very well equipped for that kind of reliability and uptime. So everyone pretty much runs it on cloud. And I understand, having, running it on cloud is kind of a form of decentralization, but you kind of deal with that as you go. I mean, as long as not everyone's running on the exact same cloud, right? Which they're not. There are lots of cloud providers out there. Some people do run it. Yeah, we actually have quite a few validators that do run it on their own machines. So there are definitely people who are very, very committed to decentralization.
What that comes down to is like your internet service provider or ISP, the bandwidth on your network, the machine stability. Does your machine crash out on you? Your power source. Do you guys get a lot of outages in your area? So there's a lot of things you have to think about when it comes to that and running your own infrastructure in your own home.
Yeah, exactly. You have to think about that, right? So I mean, I guess kudos to the people that run these in their houses, because they need to deal with a lot of stuff, right? Which I actually don't even want to deal with myself.
Right.
So,
yeah.
It's a tall order. Yeah. But, kudos to that.
Okay. Now, the next thing I want to cover is, what do you think are some of the new projects you want to see build on top of the Taraxa network? Yeah, are there any specific use cases you want to see over the next 6 months, 1 year, 2 years for the network?
Yeah. So I think in the immediate, this is actually very interesting. So we are a layer one. So we are a general purpose infrastructure. So I, as the co-founder of a layer one, I welcome any and all applications, right? Anybody want to build anything, I welcome it. So I'm not really in a position to say, well, I don't like you.
To get picky about it, yeah.
Yeah, I mean, I can't really prevent them from doing it either, right? It's a permissionless network. Now, if you ask me as a person, what do I like personally, right? So I think personally, I'm actually pretty interested in all the social AI stuff that we've been building since, I would say, 2020. And it's very interesting because we kind of set out we were originally focused on like a lot of use cases that I thought would be interesting, which is actually enterprise and business process use cases. But then we kind of pivoted into things that are more
Mainstream.
accessible to end users, right? Because B2B use cases end users don't understand, they don't really have access to, and it's very difficult for them to kind of relate to, right? So
Yeah.
the social stuff is really interesting because it came out of a few kind of frustrations that we have. One was one one was this idea of like, how do you reward people for social bounties, right? So a lot of people were running social bounties, a lot of them still do, and when you run a social bounty, 99% of your bounty actually goes to bots and spammers, and it's just very, very difficult to do. Very, very difficult to kind of filter them out, and nobody had a good system. So,
Sure.
so we always thought, hey, wouldn't it be great if we can get all this social data and be able to analytically kind of figure out who's a spammer, who's not, who's a bounty hunter, who's a bot, and just filter them out. So that was one thing that we really wanted to figure out. Another thing we wanted to figure out was really kind of getting frustrated with working with influencers. And then the reason was because it was very difficult to quantify influence, right? You never know, like if you're working with someone, how real like their numbers are. It's impossible to tell. I mean, even
Yep.
the influencers themselves don't really know that their numbers are real, because how can they tell either, right? So so there's really no way to kind of quantify that, and there's no way to kind of trace that to an end result either. So we wanted to see if there's a way for us to really quantify influence and actually be able to identify emergent influencers. So those were kind of the two frustrations that we had from just operating like a Web3 project. Before doing this project, I actually didn't really touch social media at all. Web3
Okay.
is like, it's like uber social media driven. It's uber social driven. It's like a social animal. So I started, getting this very painful crash course in how social media works, and I didn't really like a lot of the things I was seeing. So what we did was we started looking like, what are some of the things that we wanted to do, and we discovered that there wasn't really any way that we could get Telegram data. So the two largest social networks in crypto is Twitter and Telegram.
Telegram. Yep.
And Twitter, there's like 1,000 different vendors out there doing Twitter stuff. But there's exactly zero. Even today, there's zero people actually offering Telegram data. So we actually built this decentralized network that was able to monitor and ingest massive amounts of Telegram data, conversational data from public English-speaking and crypto groups, and so that right away we started, building prototypes and actually getting other developers to build prototypes of the things that we actually wanted to see. So we had a product that did social bounties, automatically. It was able to actually understand what you're saying was relevant to what someone wanted to hype up. And it automatically assigned you a amount given on its estimate of how many impressions generated. So it's, again, like, true to the mission.
Wow.
It was introducing automation because it was able to be trustless. So this, in a way, was really rewarded people for having organic conversations about any specific topic, and they could claim, whatever reward they get.
That's
And so
that's
that
one
was,
of the no, let me stop you there. That's
yeah,
one of the things I've noticed over the last 6 months to 1 year when I've analyzed my social media data is the conversations you have play a big aspect in the overall numbers, whether it's boosting the initial post when you make a comment underneath. So say I do a post and I reach 5 to 10,000 people, but then I get 50 comments on it. And when I respond to all 50 of them people who comment, then I might reach 25, 50,000 people on that post because it gets amplified by me interacting with my community. And
yeah,
that's been one big aspect that I really appreciate about Elon taking over Twitter. But because I've been on Twitter for 10, 11 years now, and that's something that I never really paid attention to. I usually only commented back on 1 to 2 of the comments underneath one of my posts. But now that I get that amplification, I make sure to comment back and interact with everybody who interacts with me. So that helps garner more impressions, helps it get a wider reach. And that's one of the, you said the analytics on Telegram. How does that convert into the impressions and reach over there?
Yeah, so Telegram, I think the impressions on Telegram is an estimate, right? So
Okay.
the thing that we did was first of all, the number of people online inside a group is a very inflated number because you don't know how many people are online and that they're just bots or whatever.
Or not even using their Telegram
Or
account.
not
I have
exactly.
friends that have a Telegram account. I ain't talked to them in 2 years. Like, what the hell? But you're still in all these groups, and it cracks me up.
Yeah, so we did an estimate. I mean, we start with a sort of the lowest possible number, which was how many people were literally talking in the group in like the past 15 minutes or something. Then you know
Okay,
they're
yep.
online, right? Because they
Yep.
said something. And then you say, well, let's multiply that by a multiplier, scaled up by how many people are online. And the multiplier is log linear, so you're not really kind of scaling up by too much. You're just kind of assuming that, because there are a lot of people who just read and not really say anything. So you just
Yep, for
assume that
sure.
it kind of amplifies a little bit. So that's kind of like a rough estimation. That's like the first pass. So that was an interesting application. And then through that process, I think another engineer thought that, hey, actually it was very interesting that we could actually use the conversation we see on Telegram to detect trends, right? So this was something that like VCs have been kind of telling me for a while. They said that they really need to find trends early, like really early. They said by the time it's trending on Twitter, it's too late. Like I want to find the trend early, early, early. And so this engineer, what he found was that the trends on Telegram can be detected way earlier, days if not weeks earlier than Twitter. Because
Wow.
just like what you're saying is that the organic conversation really is what triggers these trends, right? The trends kind of grow out of it.
Yep.
So there were several very interesting cases where we saw, I think last year Pepe came out, and we kind of did a back testing to see how early we could detect Pepe. And we were able to detect Pepe as a keyword even before the coin was deployed, right? It was as a keyword. We detected it 3 weeks before it went parabolic, and even 1 week before the smart contract was deployed. And it was very clear. It was a very unambiguous signal, which is that if you track everyone who kind of talked about meme coins, and the way we kind of did that was, let's find all the people in like the past 6 months that have been talking about Dogecoin, right? And you kind of assume that the people who talk about Dogecoin tend to talk about other meme coins. So you kind of follow these people and see what they're talking about in Telegram. And
then you measure that based on, okay, you got 2,000 people that say Pepe, and okay, now that's a trend that could be starting up, and you look more into that type of data.
Yeah, it's not just number of mentions. It's more of like it's more mind share, right? Because they're talking about a lot of different things, and so the idea is sort of like what percentage of time they're talking about different things. And we use like these natural language processing algorithms to extract entities from sentences and try to find nouns, right? Like what are they talking about? So it come up with a lot of different things, and Pepe was one of these nouns. It didn't know what it meant because it's not really a word, but it was this word that was dominating the conversation. It squeezed out, like the way it went is that it squeezed out all other topics of conversation very dramatically within the course of a week. Like everything else just got squeezed out. And everyone suddenly was talking about Pepe. And that was, remember, 3 weeks before it went parabolic. So something was happening there. That was the trend. And there are a lot of examples like that. The 3 week number is pretty up. Like you don't always get 3 weeks. But with trading algorithms, you don't need to be 3 weeks early.
Right.
You can be like a few minutes early, and you're good.
Good to go. Right.
So yeah. So I mean, so that was another interesting project that came out of it called TrendMoon that specifically looked at the trends that it could detect and was running a lot of trading bots based off of these trends and just trading on it. So I think it did pretty well in backtesting. It beat Ethereum by 8 times over the past 20 months. So pretty well. So I think they're pushing that forward, getting a lot of interest. And there's just a lot more things I think could be done on social. And so when we talk about these type of things, I mean, I think we talk about how can decentralization introduce efficiency, reduce friction, right? So I think having a decentralized data source and eventually decentralized analytics can really help you to trust the data and trust the analytics so that you can say, hey, I can layer on top of it some sort of an AI agent to act on this data and act on this analytics. And I can probably even put my money in it because I trust the process, right? It's not some guy in the back like trying to screw me over, right? Because everything I can see, it's all transparently documented, right? And this is, again, the power of decentralized. You can only do this with decentralized networks. And these are the type of, I know this is kind of a long-winded, but this is the type of thing I'd like to see, which is really kind of going back to the beginning. Like, why did we build these decentralized networks? Is to really increase the amount of automation we can have because you're making things trustworthy and transparent and auditable and verifiable. So a lot more things can be automated. I mean, this is, at the very, very beginning, I've always said that blockchains or decentralized networks are far more useful to machines than they are to people. We can't remember keys. We don't automate. We don't automate anything. We just kind of mutter around and kind of be the slow, organic, cells that we are. So, with the advent of AI, I think AI agents can really take advantage of the fact that there's an underlying trustworthy process that they can really kind of, just automate everything on top of. And this is really where the power comes from. And I do think that decentralization is something that should be eventually invisibly integrated into all processes, making everything transparent and verifiable and auditable. So and that can really help to scale really the human civilization by 100, 1,000x.
Now,
So
speaking about scaling, one of the products that was recently released on the Taraxa Network was the Root Bridge to and from the Ethereum network.
Yeah.
How has that impacted the overall network itself?
Yeah, so this is one of these things that we saw as kind of a DeFi primitive, right? So I'm personally not a fan of finance, but DeFi is has become such a core aspect, I think, of decentralized networks. So we realized that obviously you need a cross-chain liquidity. You need to make sure that assets and information flow between different networks. Yeah, especially when we're a emergent network, a little bit smaller, we need to make sure we're taking full advantage of all the things that are available in other networks. And Ethereum obviously is the biggest network by any measure, right? So
will you guys include or incorporate other networks in the future into this bridge?
I think so, but I think maybe a more interesting thing to do would just be try to incorporate other bridges. I think a lot of the bridges today, they're kind of they don't work with you unless you already show a lot of traffic. So like the typical bridges you've heard of, people like Layer 0, Wormhole, all these bridges, like they won't integrate you unless you already have a significant amount of activity in your ecosystem. And so as we grow later on, I think it'll be interesting for us to kind of just integrate with one of them. I mean, I do take issue with some of their approaches because they are a bit more centralized than the one that we built. The one that we built is purely 100% permissionless. The Ficus Root Bridge, every single bridging transaction across is purely verified on chain through smart contracts. There's just like literally no way anyone can cheat on this. So that's not
a key
really
aspect
the case
for sure too.
Yeah, that's not really the case for a lot of the bridges today. I know they all have their own little networks or whatever, but at the end of the day, they're very central. They're very centrally controlled. So we like the fact that we have a fully permissionless bridge, and as usual, I think our team is we're decentralization purists. So whenever we build something, we want to make sure it's maximally decentralized and there's no cutting corners anywhere. So we built something that was maximally decentralized. I think the trade off is that Ethereum fees are so expensive. We can't really afford to bridge instantly because that would just bankrupt us. That would bankrupt anybody.
Right.
The cost of state root verifications on Ethereum are so expensive. Um, but we built something that was fully decentralized, and we see really bridging as somewhat of a infrequent activity if you're really looking for access to liquidity. So that has really helped, I think, the ecosystem to bootstrap some of the liquidity by, I think there were community members who set up a Uniswap pool, and then we had Dexes, right, and other kind of DeFi protocols getting a lot of liquidity from Ethereum as well. And so there's kind of this natural cross-chain flow of liquidity, which is what we expected. One of the major reasons why obviously we have this. Yeah. So
Okay.
that's it's a non-optional kind of a feature at this point. I think obviously back in 2020, right? I mean, or 2019, 2020, no one's heard of DeFi yet. But now everything's like kind of required. So you gotta have DEXs, you gotta have stable coins, you gotta have like, lending protocols, you gotta have bridges, you gotta have all this stuff. So I look at that as really just kind of infrastructural table stakes when it comes to building a successful and sustainable layer one ecosystem. Yeah.
Okay. Now, to close out this interview, earlier in the conversation, you mentioned the 2025 roadmap. Do you have a specific date on when that will be released? And any key points that the community can look for in the first quarter or second quarter of 2025?
Yeah. So, well, there's probably going to be released like first or second week of January, I would say. I mean,
Okay.
I'm the guy who's writing it, so it's done. It's done. I just need to kind of think about it for a while, make sure there isn't anything there that's
Nothing you got
crazy.
to add. I got you.
But yeah, so some of the key initiatives we have for like sort of the entire year of 2025. Number one is, I think I mentioned it before, is really optimizing the infrastructure. We've spent so many years building this layer one network to be secure, to be performant, but we need to make sure that we have time now to optimize it. So some of the big things we're going to be doing on that front is obviously throughput, TPS optimization, finality, latency optimization, and we're going to be doing a lot of benchmarking. We're going to be releasing a lot of reports, and we're going to be making a lot of noise around those reports because there's just too much lying going on right now. I think within the layer one world with all this technical stuff, we want to make sure the things that we release are understandable, easy understandable, backed by third parties, and also verifiable. Very important. Anybody, with half a bit of knowledge in blockchain can verify easily on their own. So
Okay.
this is very very important to us. Yeah. The second thing I think we're gonna focus on. It's not really a focus because we don't foresee it taking up a ton of time. There's really this idea of post quantum readiness, right? So I think with Google's release of their chip,
Willow.
the Willow chip, yeah. So I think the thing that was so unique about it was that it showed that it can have a way to kind of scale up the number of qubits while reducing the amount of faults. So that was new, right? So that's very very interesting. So that really paved the way into the future that people can foresee kind of a much easier time to scale up without having to suffer increasing number of inaccuracies. So a lot of people are getting concerned now, but obviously, quantum computers are nowhere close to being able to crack like Bitcoin or Ethereum or any
Right.
of the classic. But it's good to be prepared, right? So we're going to be introducing post quantum cryptography into our VM and slowly kind of in parallel introducing all of this stuff into the into other data structures that are inside the network. And we're
Let me
also
stop you
going to.
there. In the
Sure.
future, if quantum computing ever has an effect on the overall blockchain industry, will there ever come a day where a hard fork would come into fruition inside the BlockDAG infrastructure? Whether
Um,
for you or another network, is
yeah,
that
yeah, yeah,
possible?
yeah. So realistically, because we're still so much smaller than everyone else, I think I think we're definitely not the first or even the 10th attack target. So I think what would happen, what's most likely to happen, because everyone's kind of speculating how this will happen. I think most likely what will happen is a researcher will kind of do a demonstration. So kind of a white hat hacker will do a demonstration and responsibly disclose it. So responsible disclosure in white hat hacking is you actually tell the people that are running these things and be like, hey, I was able to hack it. Here's how you can reproduce it. I will give you 3 months to fix it before I tell everyone else about it, right?
Right.
So I think that's probably the most likely thing to happen, because a lot of the kind of the malicious actors out there, I kind of doubt that they're going to be this technically sophisticated to be able to add this cutting, bleeding edge of this kind of technology.
I was talking more the blockchain itself, the BlockDAG infrastructure, that type of a network.
Mm-hmm.
Is it possible for a hard fork in the future to counteract quantum computing?
Yeah, yeah. So the way, I mean, there's several ways to do it, right? So, I mean, you're talking about kind of a non-backwards compatible scenario in which everyone has to like right away give up all their classical cryptography, right? Like basically you can't use like elliptic curve cryptography anymore
Right. You got to move to
because
something new.
you
Right.
got to move to something new, right? Like one of these four candidates proposed by the National Institute of Science and Technology, for example. So yeah, that I think that can happen. Well, it's gonna happen at some point. It's just
Right.
a matter of when. So the idea
I
for
just wanted the end users to understand if it ever came to that fact for the Taraxa network, there is the ability to make a transition in the
oh
future.
yeah,
You
yeah,
guys
yeah,
are not stuck with old cryptography if something new is available.
yeah, definitely. So the post quantum readiness plan is to make sure that both types of cryptographic primitives are going to be built into the network and ready to go. As soon as we hear someone say it's been
Hey,
hacked,
it's time to go. We got to
let's
fire this
switch.
up.
Right? Let's
Right.
switch. I think it's the world is because it's one of these things where like if we're the only one that's making the switch and no one else is, it doesn't work because there's no post quantum wallets, there's no post quantum anything. I mean,
It
like
doesn't make sense. Right.
people can't even use it. And then obviously post quantum cryptography is also really really slow compared to classical cryptography. So it's about 3 times, 4 times slower. So if we're the only one doing it, then we have to recreate an entire infrastructure of ecosystem of tools for everybody, and that's not smart. That's not smart. So
One last thing right there. When you just mentioned that, I was thinking about, you said 3 to 4 times slower, but if the overall network all advanced to that new infrastructure, wouldn't you have a faster ecosystem overall if everybody was running on quantum computing infrastructure? Or am
if
I seeing
everyone had
that wrong?
if everyone had a quantum computer, then maybe. But
That's
I
50
mean,
years down the line. We ain't
yeah,
thinking
quantum
about that.
computers are exorbitantly expensive right now. They're so
Yeah.
expensive. I don't even think you can buy. Like, if you call up Google today and try to buy one, they're probably going to tell you no. Like, we don't charge.
Right. It's out of here.
Yeah. So now that might change very quickly, but I don't think that's like next year I'll be able to buy. I don't think that's going to
Right.
happen.
No,
Maybe
I
10,
gotcha.
20 years down the road.
Yeah.
But you're right. Like assuming if people started running quantum chips in their computers, then yeah, it wouldn't really matter. But again, I have no idea when that's going to happen.
Right.
I think there are a lot of these projects who are saying like they're quantum resistant, that are trying to kind of fan the fear, like, oh my God, it's happening next year. It's not happening next year. I mean, no respectable expert in cryptography has ever said that it's happening. Everyone said it's still far, quite a ways off. So, you gotta listen to the people. Sometimes you gotta, to really learn the truth, you gotta listen to people outside of crypto. Like what are those people saying who don't care about your cryptocurrency, pump and pump scams? And they can, they say what's going on. And again, like, people like the National Institute of Science and Technology, they're releasing these candidates or reviewing. They're reviewing the candidate. The next meeting in 2025, they're going to review the implementations. I mean, they're doing this very methodically and, whatever. So you got to follow the standards, right? Like, if you do it too quickly and made up your own crypto, it's a recipe for huge disaster.
Risking, yep.
Yeah.
All right. Yeah. Well, this
yeah.
has
So
been
I think those are some of the things that we're going to focus on from a development perspective. But yeah, we're also going to focus a lot more on in-person business development with developers as well as other projects, because we found that it's a lot more effective. It's slower, but it's a lot more effective at kind of converting projects and developers into the ecosystem. So that's another thing we're going to focus a lot on next year. So,
all right, great. Well, this has been Taraxa, EVM Compatible BlockDAG with Stephen Poole. Thank you for being here, brother.
Thank you very much for having me. This is a great conversation. Yeah, thank you.
Yeah, this was a good one. We'll definitely have to follow it up in the early 2025.
Awesome.
Thank you for being here, brother.
Thank you very much, Josh.
Bye-bye.
The Crypto News Podcast with your host, Joshua Roomsberg. Follow and subscribe today.